Hello friends, in this video we will explore how to automate handling slowly changing dimensions (SCD) using delta tables in Databricks with PySpark. Specifically, we will cover SCD types 1, 2, and 3, and show you how to write a user-defined function (UDF) to manage these types efficiently. Manually implementing SCDs can be time-consuming and error-prone, especially with a large data set. Automating this process with our function will have save time, reduce complexity, and ensure accurate historical records. By the end of this tutorial, you will able to handle SCD updates quickly and efficiently, optimizing your data processing workflows in Databricks. Okay, let's break down the process of the working UDF function and automate SCD function step by step. First we need with the parameters the source data delta table path and column like primary key updated column and the date columns we will use for tracking change. Okay, you can see here. And then check if delta table exists. If it does not exist, we load the existing delta table and check if any added columns like a timestamp are needed. And add the effective date to the source data and define condition to track change. Perform a delta merge. Perform a delta merge for matched records. We update them, change data, set the end date, and mark the record as not current. For new records, we insert them, set the end date to null, and mark them as current. If data table not exists, we simply create a new delta table from the source and include the necessary columns for tracking. And finally, in the end, the process ends after the delta merge operation completes, ensuring the delta table is up to date. Okay, let's review the SCD handle function. Let's begin by defining the parameters we need for our function. We have this source data frame, source df, the path to our delta table. Delta table path, and the primary key, which will be used to identify records in the table. And okay, you can see here parameters, okay, here, and I explain about them. For example, Spark Session, source data frame, path to data table, like a list of the primary key, and a list of the columns to update in SCD2, and other parameters. Okay, and now check if delta table exists. We first check if the delta table exists at the provided path using delta table, that is the delta table function. If it exists, we proceed to load the table into target underscore df. If not, we will create a new delta table. And the audit columns, if we are tracking added columns like create add and update add. We will add those to source data frame, source underscore df. These are important for traceability, specifically when dealing with historical data changes. And set the effective and end date columns. Next, we add effective date column to the source df with the current timestamp. If the table doesn't exist, we also initialize the end date column as a null and set the current flag column to true for the newly inserted records. And now, merge condition and update condition. The merge condition is constructed based on the primary key. This key helps us match records in the source data frame to the target data table. We also define the update condition, which check if there are any updates in the columns that we care about. Okay, now perform the delta merge, and now we perform the delta merge operation. If records the target table match the source, we update them with new values, including setting the end date column and current flag column. For unmatched records, we insert them with their required values and set the current flag to true. Okay, I must mention is a default value for SCD type that must already implemented this function is 2. Okay, SCD type 2. And if you need SCD type 1, okay, automating SCD type 1, you must change these parameters to 1 or 3. Okay, and and finally, if the data table doesn't exist, we handle this by adding the required columns like effective date columns and end date columns and current flag when they write the source table as a new delta table. So you can see based on your input, I mean SCD types. Okay, this function implement related SCD type. For example, if you enter 1, okay, here implemented this this SCD type overwriting matching records and insert new records. If it be 2 SCD types, keep history of the changes, and finally if you enter 3 SCD type, keep current and previous values for history for specific columns. Okay, and now we want test the code with the sample data. Initialize data tables for SCD types 1, 2, and 3. Now we initialize our delta tables with some initial test data for each SCD types. We will create 3 delta tables, one for SCD type 1, one for SCD 2, and 3. Okay. For SCD type 1, we begin by setting the initialized data for SCD type 1. This type simplify overwrite records, match on the primary key, and insert records. Okay, you can see here. This is after define this data frame, insert to this delta table, the data table SCD1. Okay, and here define a new data source, okay, that we will use it when we want execute function. And yeah, for SCD type 2, we include additional columns like here. Yeah, we begin by setting up the initial data for SCD type 2, and we add columns like effective date, end date, and is current to keep track of the historical change for each records. And finally, for SCD type 2, we add a previous city column to track the previous city value for each records. Okay, in the last part of this tutorial, okay, we check the final result. Okay, here I insert parameters in function in this function for SCD type 1, here SCD type 2, and SCD for type 3. Okay, and for source df parameters, I use this one. Oh, sorry. Yeah, I use this data frame, and for SCD type 2, this one and this one. Okay, and after this function for different SCD different types, I get this result set. Okay, for SCD type 1, 2, and 3. Okay, the SCD type 1 logic is simple. If your records already exist with the same primary key, we overwrite it with the new data. No historical records is kept for previous value. In this case, after running the test for SCD type 1, the result set is shown here. Yeah, and yeah, okay, and the data table is updated with the latest data. For example, with see David, age is 28. Okay, 28, and his city is for San Francisco. Okay, and San Francisco, there is no historical data kept, so Alice's previous city or age is overwritten. Okay, Alice is Alice and 32 and Boston. And here it's a previous city that Alice lived there. Okay, and second is SCD type 2, preserving historical data with the effective and end dates. We preserve data history by adding effective and end dates. That is current columns track whether a record is active. Yeah, and David here. David has been inserted with the effective date of 2021-22, and active is current flag set to true. Alice's record was marked as inactive, and end date was set to the current stamp, preserving that she is no longer current. Bob and Charlie records remain active with a null for boost, end date, and effective date. And for Yeah. And testing SCD type 3. In this SCD type, we maintain both the current value and the previous values for selected columns. Here we are tracking the city column. Alice's record shown that her city has been updated to Boston, while previous city columns show her previous value of New York. David and Bob and Charlie's records show null in the previous columns because they were either newly inserted or their cities haven't changed. Yeah. So SCD type 1, the current value are overwritten with a no history preserved. SCD type 2, the historical data is preserved by adding effective date and end date. Oh yeah, let me show all. And SCD type SCD type 3, only the previous values for selected columns like city is retained the previous city column, allow the tracking of the changes while keeping the most recent value in the main columns. These results show how much slowly change dimension type handle updates, ensure that your data warehouse or delta table can accurately represent historical changes depending on your business requirements. Okay. This function makes handling slowly change dimensions SCD in Databricks super easy and efficient. Whether it's type 1, 2, or 3, the logic is automated, reusable, and scalable for any dataset. It saves you from the repetitive and time-consuming of manually tracking changes, making your workflow smoother and faster. Plus, I have optimized the function with a feature like a schema validation audit. Oh yeah, here you can see. Okay, yeah, yeah. I have optimized the function with the with the features like schema validation, audit columns, custom update condition, and more to ensure flexibility and reliability for your projects. The full code is on my GitHub, and the link is the description. Check it out, try it out, and let me know your thoughts. Thank you for tuning. Like, comments, and subscribe for more tips and tutorials. See you in the next video. Bye.